Hey folks, thank you for joining us today. My name is Blaise Pele, and I'm a Principal Product Manager on the AWS AppSync team. I will be joined today by Alex Debris, a consultant and AWS data hero. Today, we are going to be talking about DynamoDB design patterns with GraphQL APIs and AWS AppSync. Our agenda is going to be as follows. We are going to talk about GraphQL, just give you an introduction to what GraphQL is and where AWS AppSync comes into the picture when we talk about GraphQL. Then I will be handing it over to Alex to talk about design patterns with DynamoDB and how you can really fully leverage DynamoDB in your GraphQL design. To get started, I'd like to talk a little bit about GraphQL. GraphQL is a new concept for many, and I wanted to take a bit of time to just go into some of the details and provide an introduction to what GraphQL is. So, the first question that you may have is exactly what is GraphQL? And what I'd like to do when I talk about GraphQL is simply go to the definition that is on the GraphQL specification website. And it simply states that GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. I like to underline three key parts of this sentence: query language, runtime, and existing data. What GraphQL allows you to do is essentially describe the data that you want to interact with types in what we call a schema definition language, and then it allows you to ask for what you want. And because you can be really specific about what you want, you get predictable results. So you ask for data in a certain shape, you get results back in that specific shape. So GraphQL specify a language that allows you to query for your data, and then those that query needs to be resolved in a backend, and that's where the runtime comes in. And then the key thing is that it lets you connect this API to your existing data. So GraphQL doesn't come with any preconceived notion about where your data should be stored. You can store your data anywhere. You can use your existing data and then have GraphQL connect your APIs to your data. So maybe another way to explain this is to look at what typically happens in a REST environment. So with REST API or RESTful APIs. Let's take this example here where we have an application that's running on a desktop and we have another version of this application that's already also running on a mobile device. The application is made up or consists of three different parts that we've got here in green, blue, and red. So you could have three different, maybe like paragraphs and images and user data. And so what typically happens here is that you have your application on your desktop that displays a lot of data. So that application typically fetches a lot of data. On your mobile application, you have a version of the same application, but it's running with different requirements, right? It has smaller real estate, so doesn't necessarily need to show as much data, doesn't need to retrieve as much information to display to users. What typically happens in a REST with a RESTful API is you have these different resources. And what is going to happen is when you want to interact with those resources, you're going to have to make separate requests for all of those resources. Now, here, we're kind of displaying three different endpoints, A, B, and C. You may have different endpoints, or you may have all of these resources being fulfilled by one endpoint. But what usually happens is that you have to make separate requests for all of those resources. You also have to make these requests in sequence, especially if there are relationships between the different data types. So if there's a relationship between your data A and data B, you first have to get data A and then figure out what you need to get from data B and then figure out what you need to get from data C. So you have to do those in sequence and you've got to do multiple requests. And then on the mobile side, we talked about the fact that mobile doesn't need to necessarily display as much data, right? So the desktop application shows entire paragraphs. The mobile application only needs to show a summary. So while the mobile application doesn't need to get as much data, it can't really specify that it only wants to get a subset of the data that you would see on the desktop application. So that's kind of the stuff that you typically see with RESTful APIs. If you look at what happens on the GraphQL side, the first thing that you notice when you interact with GraphQL is you only have a single endpoint. So you only have a single endpoint that is connected to all of your resources in your backend. And this connectivity, this connection to your data sources on the backend is something that is not exposed to the client. So you have a GraphQL API here that's connected to a SQL database, microservices, and maybe some NoSQL database. When your application wants to make a request to your GraphQL API, it only sends a single request. So your application can request data A, B, and C in a single query to your GraphQL API, and your GraphQL API knows how to resolve all of the different fields that are requested by accessing data from different data sources. It knows how to resolve the relationships, so they are not you do not need to make multiple requests to your backend just to get the data that you want. So you kind of save on performance by doing that. And then on the other side, we've got a mobile application. As we mentioned, the mobile application doesn't need as much data. Your mobile application can then specify exactly what it needs. It may be a subset of the data, but it can specify that it needs a subset. It specifies the subset into shape, and it only gets the subset that it's requested into shape that it requested. So when you get that data back at your mobile device, not only are you fetching less data, which saves on to connection and to query that you do over the network, you also get the data back into shape that you expect it to be in. So your mobile application doesn't have to waste cycles parsing, transforming, and filtering that data just to project the needed information to the application users. So that is one way of comparing and GraphQL. So if we look a little bit closer at what GraphQL is, we talked about the query language for your APIs. There's a couple of important concepts that GraphQL introduces. GraphQL introduces the concept of a schema and a schema definition language. A schema is a document that allows you to define the data that you're going to interact with and how you are going to interact with that data. It does this by allowing you to specify types. So types essentially represent the data that you want to interact with. Here you see an example of a user type. And the user type is made up of fields. So for example, we have an ID field, we have a username field. Each field has a type of its own. So the ID has a special type called ID, which is just an identifier. The username is a string. And you see the exclamation mark here, and the exclamation mark essentially means that the username is a required field, right? So when I interact with a user, I'm always going to have a username because it is a required field. On the other hand, you can have a first name that's also of type string, but it's not a required field. So this information is not always going to be there. It is optional. Then to interact with our data, we have operations. And there are three operations that GraphQL introduces: queries, mutations, and then it introduces a new concept of subscriptions. Queries, as the name suggests, allows you to to fetch your data, so to get and list data. Mutations allows you to change data, create data, delete data, update data. And then subscriptions allows you to subscribe to changes that are occurring in your GraphQL API. So essentially, it allows you to subscribe to changes done by mutations. So if I were to do a mutation that were to change user information, a client could subscribe to those changes and get notified in real time of those changes happening. So pretty interesting concept that GraphQL introduces. When we look at the operations, queries, mutations, and subscriptions, this is essentially how you would define your operations. So you define a query, and then in your query, you can specify the exact data that you want to get back. So here we're doing a get post, and we specify the ID, and we say, well, I want to get a post, and I specify the argument, which is the ID. The ID is 1. And I want to get back my ID, the title, the author, and the date. The box that you see in purple here is what we call a selection set. The selection set allows you to specify the set of fields that you want to get back. And you can do this for mutations and subscriptions as well. Now, the powerful thing about selection set is that it can vary based on your use case. So here, if I have a query and I'm doing a get post, I may only want to get the ID and title back. So I can specify that and save on the amount of data that is sent back to my application because I don't need the rest of the data. Similarly, when I do a mutation, I'm going to create a post and I've got my input argument that specifies the data to use to create my post. And then when the post is created, Maybe I only want to get the ID and the date back. I don't want to get the rest of the information. And then for the subscription, same thing. I want to subscribe to changes, but I only want to see the ID, title, and the author fields. This is pretty powerful because it lets application set up and let subscription really build queries and build operations that are specifically tailored to their needs. So when we looked at the desktop application needs to get a lot of data, mobile application needs to get less data. So you can really optimize performance and optimize the latency and the time it takes to resolve these fields by specifying the selection set. So to sum up a little bit, what have we seen with GraphQL? There's a couple of key points here. First one is that with GraphQL, you can reduce the number of requests that you make, which is really, really great. Saves on battery time, saves of consumption, reduces latency, is more efficient for your client and your backend. You can reduce and control the amount of data that you fetch by using the selection set. And you can also receive the data in expected shape and format because the selection set guarantees that you are going to get back that data in the shape that you specified you wanted it in. You reduce onboarding overhead. We talked about the schema. One of the things that I didn't really show into schema is the fact that you can actually document your types and document your queries. So schema is a self-documented document, self-documented document, and it makes it really easy for developers to get started with an API. GraphQL also supports the concept of introspection. So by running an introspection query on an API, you can actually find out the capabilities of that API. And by looking at the schema, reading the documentation, reading the comments, developers can really easily get started with an API and implement their application. You can connect to multiple data sources. So you connect your data. Like I said, there's no preconceived notion about where data has to be stored, and you receive real-time notifications. This is really important if you want to implement real-time application and applications that need to get notifications. You can reduce the delays that it would take to get updates to your application, and you can pretty much eliminate polling. So you have a lot of applications like dashboard and chat messages that implement polling because they want to get updates as fast as possible. The problem with polling is that it's pretty intensive process when it's repeated on the client, and it adds a lot of pressure on your backend, meaning that you have to set up more and more resources as your usage grows to support all of the polling that is done on your backend. So GraphQL with subscriptions and real-time notifications can help you eliminate that. So with GraphQL, you get exactly the data you need, nothing more, nothing less. That's what the query language allows you to have. Now, let's say we've talked about GraphQL and this sounds great. You want to implement GraphQL in your own application. You do have to worry about the runtime, right? So you do need to fulfill those GraphQL queries somewhere, somehow in your backend. And you have a couple of options. You could choose to roll your own API, or you could choose to use a service that provides fully managed GraphQL endpoints. And this is where AWS AppSync comes in. AWS AppSync is an AWS service that allows you to build scalable applications on a range of data sources, including those requiring real-time updates and offline data access. So, in a nutshell, AWS AppSync is a managed GraphQL service that allows you to configure serverless GraphQL endpoints that you can use right away in your application, and that allows you to connect to data sources in your AWS account. Managed GraphQL service, but it's also a lot more than that, and I'll give you a bit of information about that as well. So, how does AWS AppSync work? Well, it's fairly simple. It allows you to connect any type of application. So you can start with enterprise application, web and mobile apps, real-time dashboards, IoT applications, and even applications needs to implement offline functionality. Applications connect to AWS AppSync, and AWS AppSync provides the GraphQL endpoint and allows you to connect your API to data sources in your AWS account. Out of the box, AWS AppSync allows you to connect to DynamoDB, which we're going to talk about in depth in a little bit, Amazon Aurora Serverless, Amazon OpenSearch, AWS Lambda. You can connect to any HTTP endpoint as well, and you can connect to any AWS service by connecting to the service API. You can also push changes directly to AWS AppSync without having them saved anywhere by using what we call local data sources. So local data sources allows you to push data to AppSync and have it pushed back to the rest of your clients without um, uh, without storing the data anywhere. So AWS AppSync, you see it here, provides the GraphQL endpoint, and it allows your application to connect to a single endpoint and hides a lot of the backend complexity that is happening. I mean, this is something that your clients just don't necessarily need to be aware of. All they need to be aware of is the schema, the types, the queries, the operations, and interact with that. And into backend, there's a lot of complexity going on. There are fields that are being that are being implemented by different resolvers and that are connected to different data sources. So in this example here, you see that we're getting back data, we're getting profile information, and we're getting order information. Profiles are being retrieved from your DynamoDB table. Orders are being retrieved by Amazon Aurora. You got in stock information, inventory information that's being retrieved by OpenSearch, and then price information that's being retrieved from AWS Lambda. All of this can happen in a single query. You do not have to make multiple requests to get this information. So in a single query, we're getting a lot of data. We're interacting with a lot of different data sources. Now, this is pretty powerful for your applications because they do not need to worry about that backend complexity. All of this is being exposed in a single query. So within the AWS AppSync system, we have this GraphQL API. We always take security very seriously, so everything that is going on within the AWS AppSync subsystem is secured by default. Working with AppSync, working with GraphQL, you often start with the schema. This is where you do your data modeling, you define your types and your operations. And then when you define your types, you then write resolvers. So resolvers is a GraphQL concept, and resolvers essentially allows you to specify the business logic that tells AppSync how to retrieve, how to fulfill fields from the data sources that you have configured. So if you have a field, you write your resolver that essentially tells AppSync how to fulfill the request. This is where you write your business logic. So it really allows you to do pretty much anything that you want, and for you to implement use cases that are specific to your application, and then get those resolved by the data sources that you've connected. You can also use what we call pipeline resolvers. So I mentioned the fact that a field is resolved by writing a resolver that then connects to a data source. But you can resolve one field by connecting to multiple data sources, and you can do this with a pipeline resolver. Pipeline resolver allows you to interact with multiple data sources for a single field. So you could have a situation where you need to resolve a field. So, and maybe you need to get that data from a SQL database and a bit more data from a NoSQL database. And then maybe after that, you want to pass that data to a Lambda function or a microservice to massage and transform that data before returning it. You can do that very easily with a pipeline resolver. We can also use what we call direct Lambda resolvers. So if you want to just skip the resolver onto AWS AppSync side, you can write your entire business logic in an AWS Lambda function. So you don't have to write any resolvers. You just connect your Lambda function, and your Lambda function now becomes responsible for implementing the business logic and providing the data. So this is another way that you can use AWS AppSync to interact with your data sources. And AppSync also provides real-time data broadcasting. This is what is provided by subscriptions. So it's very simple to implement a PubSub API using AWS AppSync. With the PubSub API, you can process ephemeral messages and updates to persistent data. We talked about the fact that we have local data sources. Local data sources essentially allows you to publish information directly to AppSync without having it persisted or stored anywhere. But as you publish this information using a mutation, you can then use subscription to broadcast that information to all of your subscribed clients. So writing a PubSub API to implement things like pager application, chat application, stock and dashboards is really simple to do with AppSync. The way we implement real-time broadcasting is with secured WebSockets. So AppSync takes care of all of the heavy lifting of implementing your WebSocket. Your clients simply have to subscribe with the subscription using one of our clients, like the Amplify client, and we automatically set up the WebSocket for you. In one WebSocket, you can set up multiple subscriptions, and then the WebSocket is established, and that means you've got that essentially semi-persistent connection, and notification can be sent right away over to WebSocket without having you to poll or to reestablish your connection. And any changes that is done on the AWS AppSync side is then pushed to the clients that have subscribed using the WebSocket. So AppSync, a managed GraphQL API service, but much more than that. We went through a couple of the key functionality that AppSync provides, but there is a lot more than AppSync can do. We talked about the fact that it allows you to provide pub/sub functionality. Along with that pub/sub functionality and the subscription functionality, we provide enhanced subscription filtering functionality. So you can have multiple clients that subscribe to different things in your API, and you can provide filtering to make sure that specific clients only see a certain amount of data or certain type of data based on the rules that you have set up on the AppSync backend. We support multiple methods of authorization right out the box, so there's nothing that you need to implement, whether you want to use API keys, whether you want to use something like Amazon Cognito User Pool, or your own OIDC provider, or IAM credentials, or if you want to roll your own custom authorization, you can use a Lambda function to provide that functionality as well. We support AWS WAF integration, so the web application firewall for an extra level and measure of security to filter requests, to deny requests. You can do that as well. You can bring your own domain if you want to set up your own domain with a custom domain feature. We have configurable batching, which is really important if you've got data sources and you want to optimize the way you fetch data from those data sources. We support caching with custom keys. We support cache invalid item eviction as well. So this can help reduce latency on your AppSync API by avoiding fetching to data sources for every single request. We support a ton of utilities that allows you to easily work with our resolvers into Velocity Template Language, VTL. And at the end of the day, you can connect to any AWS service. So you can use AppSync to connect to any AWS service in your AWS account. AppSync essentially becomes the gateway to all of the data sources, all of the functionality that you have in your AWS account. So more than a GraphQL API service, there's a ton of functionality and a ton of features that you can implement using AWS AppSync. So this was my overview of AWS AppSync to get us started. What I would like to do now is hand it over to Alex to dive into AppSync with DynamoDB and go over some of the design patterns. Alex, over to you.
Thanks, Brees. That was a great overview to GraphQL, to AppSync. And yeah, as you mentioned, I'm going to talk about using AppSync specifically with DynamoDB and some of the interesting things to think about there. I want to talk about this on sort of three different levels. First, we'll start off just talking about, what is DynamoDB, and just give, if you're new to Dynamo, just give you a sense of what DynamoDB is about, what makes it distinctive, and things like that. Second, we'll talk a little bit about just general data modeling with DynamoDB. We won't go super deep here, but I just want to introduce a few concepts that are going to be interesting. And then just getting into the meat of it, where there's this concept in DynamoDB called single table design. And just, if you're using GraphQL, using AppSync, should you use single table design? Should you use multi-table design? And some of the factors to consider there. So we'll walk through that. We also have a write-up of this, and we have a few different repos you can look through for that sort of stuff. But I want to introduce those concepts here. So I'll start off and just talk about, what is DynamoDB first. And at a very high level, Dynamo is a NoSQL database from AWS. There are a lot of different flavors of NoSQL database out there. So I want to give you even a better sense of what makes Dynamo unique and distinctive. I think its most distinctive characteristic is that it really gives you consistent performance at any scale, and it does that through horizontal scaling. So if I think about a normal traditional database, it's usually, a single instance, something like that. If I'm running Postgres, MySQL, Oracle, something like that. DynamoDB is not that. It's not going to be a single instance. What's happening with Dynamo behind the hood is it's actually splitting your data into multiple different partitions. And each of these partitions is just holding a subset of your data. And the great thing about this is that as your data set grows, they can add more and more partitions and allow you to scale up. So I talk about DynamoDB's consistent performance a lot. And just to give you a flavor of that, I like to show this chart where on the x-axis, we have data size, right? So that's as you go further out on that x-axis, you're just increasing the amount of data in your actual database. On the y-axis, we have performance. You can think of it like latency, right? The higher you get here, the slower your application is going to be. If you're working with a traditional relational database, maybe something like MySQL, you generally see a performance curve with this type of general shape, right? And the numbers may be different, but the idea being as your data size increases, your latency gets higher, you get a little more sluggish with your performance. To contrast that with DynamoDB, what you're going to see is a performance curve that's pretty flat, right? You're going to see the same performance running locally, running in a test environment as you see, many years down the road with terabytes and terabytes of data. So I think that's one of the most interesting things about DynamoDB. It really gives you that consistent performance at any scale. And the mechanism it does it is through that horizontal scaling, which is common to NoSQL databases. Now, additionally, with DynamoDB, what you get is a very focused API. And I think this trips people up just because you don't have the same sort of flexibility that you have in a relational database. Let's look at some example data here. And you can imagine these are orders in an e-commerce application. I have a couple different attributes here. I have customer email, order date, order ID, order total, things like that. If you look on the left two columns, I have that what's called a primary key. And that's what you're going to query your data with. All your queries are going to be using that primary key. So in this case, customer email, order date, very easy for me to query my table based on those attributes. But I won't query based on with those other attributes. I won't be using those in my query. So things like order ID, order total, not going to be as efficient to query based on how I've structured this table because it's not using that primary key. So Dynamo is really going to push you towards using that primary key in your query. And the important part about this in particular is this partition key. So we can see that first element of the primary key. It's a partition key in this case, which is customer email. I want to talk about why that's so important, why Dynamo really pushes you to that, and why it helps you with that consistent performance, right? So if we go back to, just the general infrastructure, we talk about Dynamo is splitting your data into different partitions. Let's imagine a read request comes into DynamoDB, right? Some client comes in and says, hey, get me this particular order for this given email address. And that hits our DynamoDB front end. What's happening at that DynamoDB front is it's going to pull the partition key out, which in our table is the email address. It's going to say, okay, that customer email is susan@email.com. And it's going to know exactly which partition to go to actually fetch that record. So what it's doing is when it's partitioning that data for you, it's partitioning by that given partition key that you've given it. So now when a query comes in that includes that partition key, it can quickly go to the right partition and it gives you that consistent performance, because as you scale up, you can add more partitions to your DynamoDB table. They're going to do that under the hood for you and give you that consistent performance. So again, DynamoDB has that focused API, and really it's focused and based on that primary key. Almost all the API actions you're going to do in DynamoDB are going to force you to use that primary key, so it can take advantage of that partition key and scale pretty well. Last thing about DynamoDB is it's a fully managed database, right? We're seeing a lot of databases move to being more and more managed, and you can get managed relational databases with Amazon RDS. You can get managed document databases with DocumentDB. Even those databases, they're mostly managed, but you still need to think about instances and what happens if there's failures and replicas, things like that. Whereas Dynamo, it really is fully managed for you. You're not thinking about that underlying infrastructure at all. You're just saying, hey, I want this many read and write units per second. You're saying how many reads and writes you want per second. They're going to give that capacity back for you. They're handling failure under the scenes. They're handling replication, all that sort of stuff. So you don't need to worry about it. And that's why we're really seeing it be popular in serverless applications and using AppSync and in GraphQL APIs. So that's what's sort of distinctive about DynamoDB. Let's talk a little bit about data modeling with DynamoDB generally before we get into data modeling with GraphQL. So data modeling with DynamoDB is going to be different than data modeling with a relational database. And I think the first and most important thing you need to know is you have to think access patterns first. which if you're coming from a relational database, this is backwards from how you usually do it, right? With a relational database, you think about the different entities or objects in your application, you create a table for each one, you have this nice normalized schema, and then you think about the queries to index them together to filter on different things. But with Dynamo, you have to think about the access patterns first. And it goes back to what we talked about earlier, where you have to query with that primary key, not with those other attributes in your table. And because of that, you need to think, how am I actually going to access these orders? Am I going to access them by customer email, maybe customer email and order date? Or am I going to access them by order ID or order total or some other attributes? And whatever you decide you need to access them with, that's what you're going to need to put in your primary key to actually handle that, so you can take advantage of that partitioning by that partition key that DynamoDB is using under the scenes, under the hood. So that's the first part about data modeling with DynamoDB. Think access patterns first. Another thing that's useful is you really want to rely on what's called the query operation with DynamoDB. This is a pretty powerful operation. If we go back to what we talked about before, we talked about retrieving an individual order from DynamoDB, how it's doing that with the partition key. And, retrieving an individual record by its key, that's a pretty easy operation, whether for DynamoDB, for DocumentDB, for a relational database, anything like that. Those are all pretty easy operations to do a lookup by that primary key. But you also might have, fetch many type access patterns. Like, hey, I want to get the 10 most recent orders for a particular customer. If they want to view their order history, something like that, you want to get that to them. So let's imagine we do that to DynamoDB and do that. Again, we have that partition key there, right? We have that customer email, so we know exactly which partition to go to. So this should be a pretty efficient request. And if we go back to our example data here, you can see we have 2 records with that particular customer email, joe@example.com. Because they have the same partition key, they're going to be located on the same partition. They're going to be located near each other. They're going to be ordered by that sort key. And we can do a query operation in DynamoDB that gives us that customer email, gives us that partition key, and it's going to fetch those records for us. Additionally, in addition to an exact match on that partition key, you can also have different conditions on that sort key as well. So if you want to say, hey, for this particular customer, I want to get their orders, but only if they're, happening after June of 2022, right? So I can add that condition on there. It's going to filter out those records. And because they're ordered according to that sort key, this is going to be a very efficient operation. So again, in addition to those individual item-based, key-based operations, there's also that query operation that allows you to fetch many records in a single request. All right, last thing in data modeling is this concept of single table design. And if you sort of hung around the DynamoDB world a little bit, you might have heard about single table design. So I want to give a little bit of background on that. You'll probably have to go read more about that outside of this webinar. But just give us a little introduction so that we know what we're talking about as we move into the GraphQL specific section. So if we go back to our example that we have here, we have our orders records again, and we found out we can very efficiently get those most recent orders for a particular customer. But when we're doing that, we might also want some information about the customer itself, right? And this would be something you might do with a join operation in your relational database. But DynamoDB doesn't offer joins, right? That's a join is a read time operation. It gives you unpredictable performance because you don't know how many records you're joining against, and DynamoDB doesn't want to do that. So they don't offer joins, but you still might need joins, right? And if you think access patterns first and you think, hey, I have an access pattern where I'm going to need to fetch the most recent orders for a customer, but I also want to fetch information about that customer to display on that order history page, what you can do is pre-join your items in your table and sort of materialize that join up front to take advantage of that query operation. So I'll just show a little example of what that is. We have our 4 orders here. I'm going to change our table a little bit. I've just added 1 new record in here. If you look outlined in red, these are 3 different records that have the same partition key. So again, they're going to be located on the same partition. But what we have is different types of items in this particular item collection, right? So we have our 2 order items up top like we had before, but we also have this user item down below that includes information about our customer, about our user, right? And now, because they're all contained with the same partition key, they're going to be located near each other. And I can use that powerful query operation that we talked about to fetch heterogeneous items in a single request. And this is what we talk about with single table design, where rather than having a table per entity, you might put multiple different types of entity in the same table within the same, sharing the same partition key, so you can make these queries that fetch heterogeneous items in a single efficient request. So you can do some of that. That's the high level overview of single table design. Make sure you learn more about that before you really dive into it. A couple other points I want to point out here is we need to give it those primary key values. But if we have different types of items, they're going to have different attributes. We can't have the partition key and sort key that we had before. So we're going to give it very generic names, just PK for partition key, SK for sort key, and then the values of those can vary across different items depending on how we want to structure our data. Likewise, these entities will have different attributes, right? Orders will have attributes like order ID, order total, things like that, things that are meaningful to that order, where the user or the customer is going to have their name, their country, address, different parts like that. The great thing about DynamoDB is it's a schemaless database, so you don't have to register all your columns in advance like you would with a relational database. You only have to have that primary key as part of your schema. So you still need to have a schema. It should be in your application code, and you should enforce that. But DynamoDB itself is not going to enforce that schema for you. So those are some high-level notes on data modeling with DynamoDB. Again, I think check out the other material on this. There's a lot of great material on there, and most of the data modeling patterns that you see generally are going to apply in GraphQL as well. But one thing I want to talk about is, hey, should I use single table or multi-table design in GraphQL? Because this is something that comes up a lot. I see a lot of people ask it, and I think there are good arguments on both sides, and you just have to choose which set of trade-offs you want to optimize for. So we're going to walk through this. Again, there's a write-up for this, so go check out that for a little more detail. And also, we've got 2 example applications. In terms of the background on the application, what we're building, you can imagine we're building like a blog hosting platform. Think of like, I don't know, WP Engine or some sort of WordPress site or something like that, right? Where a customer will come and create their site. So we have a site entity. Once they have their site, right, they're going to start writing posts on their site. So we have a one-to-many relationship between sites and posts. And then also users can leave comments on those posts. We have a one-to-many relationship between posts and comments. And that's just the basic structure we'll be talking about as we walk through a little bit of examples. Also, I want to talk a little bit about the structure of AppSync APIs and how it sort of fits in with this. Breeze did a great job earlier sort of outlining this, and I want to bring it more practical with our actual example that we have here. So, if you create an AppSync API, it's going to be a collection of a few different things under it. Number one, you're going to have to create your GraphQL schema, like Breeze mentioned earlier, and you can see within there we have our queries, we have our mutations, we have our types, just as Breeze mentioned. In addition, once you have your GraphQL schema, you're going to want to register what are called data sources. And data sources are just going to be, sources of data to actually handle queries to your GraphQL schema, right? And that could be DynamoDB tables. It could be relational database instances. It could be OpenSearch instances. It could be a Lambda function that can reach out to whatever. So in this case, if we're doing multi-table design with our AppSync API, we might have 3 different tables: a DynamoDB table for sites, one for posts, and one for comments. So once we have our schema and our data sources registered, then we need to connect those via resolvers, right? And what you're going to do is write some code or maybe some configuration that's going to show how to connect that schema to a particular data source. You can do that within your query. So this get site operation that returns a site, that could go to our sites table to go get that. Or you can also do that with your mutation, right? If our create post is going to go to that post table. You can also do it on your actual typed objects that you have, right? We have this site entity, and one of its fields that it has is posts, which is that one-to-many relationship between sites and posts. And you can set up a resolver just to handle that post attribute, which is maybe going to make a query to that post table to actually fetch that sort of thing. So you can make a connection there as well. So this can happen across queries, across mutations, across fields in your entities. You can hook up resolvers. So with that basic overview, let's talk about multi-table design in GraphQL. I'm going to start with that one because I think it's the default for most people. And then we'll talk about single table design as well. So if you go with multi-table design in GraphQL, what you're going to get, the benefits here, this is going to be more flexible and straightforward for you, especially in your resolvers. So one of the benefits to GraphQL is the flexibility it has in terms of queries. This is something that Breeze mentioned earlier. And I think that really fits in nicely if you're using multi-table design. So let's, we had our GraphQL schema earlier. Let's just imagine a sample query we might get. So we might have a query. It does a get site to fetch a particular site for us. In this case, we're fetching the site for aws.amazon.com. And you can see we're actually going to be fetching sort of two different types of entities here. We're fetching the actual site object, but then on that site object, we're also asking for the posts. So we're fetching some post objects entities for that site as well, right? So again, if you're doing multi-table design, the nice thing about this is this would be two separate resolvers, and each resolver would only have to focus on the particular object it's getting. The site one is only getting that site, the posts are only getting those posts, and they don't have to sort of mix that together. It's going to be a little more flexible, straightforward in your code. I'll show you a little bit example of that in a second. So the benefits of that, again, more flexible, more straightforward. The downside of that is it's going to be a little higher latency, right? Because you're making multiple sequential requests in your GraphQL backend. So let's go back to that query again and just think about what's happening as our GraphQL server is processing this. This query comes in. The first thing that's going to happen is it's going to call that site resolver to resolve that site, fetch that site object from our DynamoDB table. And then once that is complete, then it's going to move on to the nested part of that query, the post part of that query, to handle that post part of it. So what we have is sort of a waterfall-like operation, right? Where we're fetching one item. Once that is complete, we're fetching the next item. And just because the nature of that being sequential is going to lead to some higher latency there. This isn't going to be, too bad in a lot of cases, but you do need to weigh the trade-offs and sort of what you're using your GraphQL API for. So those are the key points, I think, the key trade-offs with multi-table DynamoDB in GraphQL. We have a few tips on sort of modeling if you're using multi-table, but I would say, the tips we talked about earlier, just basic data modeling tips with DynamoDB are still going to apply here, right? You want to think about your access patterns first and make sure you're designing each table to handle those access patterns. And then you also want to be using that query operation for fetch many, especially in that post context or the comments context, where you're going to be retrieving multiple of those entities in a single request. If you don't want to do single table design or multi-table design, you can also do single table design with DynamoDB in GraphQL and AppSync. I have some friends that do this and love doing it, so you absolutely can do it if you want to. Again, if we go back to our AppSync sort of infrastructure here, if we use single table design, instead of having 3 different data sources, we're just going to have one DynamoDB table, application table that all of our different resolvers go to and handle that in that. So let's think of the pros and cons of using this one, and this is really the reverse of using multi-table design. The benefits of single table design, this is going to be more performant, lower latency than the multi-table setup that you'd have there. So going back to, we talked about this being sort of a waterfall of sequential requests. Fetch the site first, then fetch those posts. If you're using a single table design, you can have a single resolver that fetches both of those, both the site and the post in a single request. Just like we saw earlier with a customer and the orders, we handle that in a single query request. We could handle that here with the site and the post objects. It's going to be faster than that sequential method. So that's the upside there, more performant, lower latency. The downside you're going to get is it's just going to add more complexity to your resolvers, and it might be less flexible to your clients, which is something that is one of the benefits of GraphQL. So you have to think about whether that trade-off is worth it. And what do I mean by complexity? I'll show you in sort of the application code in just a second. But if we just think about it conceptually, we could get this query from our GraphQL clients that they're calling get site and they're retrieving both the site and the post, right? As Brice mentioned, you get to specify what attributes and what fields you want back. But a client could also just come and say, hey, I only want the site, right? So I'm going to do that get site resolver, and all I want is the site. And what that means is our resolver has to be able to distinguish between those two situations to know what operation to do. And really what it's going to have to do within that resolver is look at the selection set list that Brice mentioned earlier and say, hey, as part of this selection set list, are they asking for that post field? And if so, I'm going to do this query operation. Otherwise, I'm just going to do that get item to fetch that site. So This is called a look ahead in GraphQL, where you're looking ahead to see nested fields, things like that. And I think the GraphQL community is of different minds on whether look aheads are an optimization that's worth doing, or whether it's something you should avoid doing generally. Again, it depends on your application needs and whether you really need that performance, or and you don't have a lot of flexibility in your queries, or and whether you're willing to take on that complexity in your resolvers. So again, those are the two main trade-offs. The last thing I would say is, like, this very much can be mix and match, right? I don't want you to feel like, hey, if I'm doing the single table to GraphQL design, every single GraphQL query that comes in from any client has to be handled with a single DynamoDB request. You don't have to do that. What you can do is choose to optimize some of the low-hanging fruit and say, hey, if sites and posts are often retrieved together, often going to, like, that's a very hot access path, maybe I can implement that part where I'm retrieving those together, but then I still have some other parts that are retrieved individually, and maybe I have some sequential parts of my Dynamo or of my GraphQL application. So you can think about that, look for the low-hanging fruit and the easy stuff, and then do the rest with sort of separate resolvers. So I'll do a quick summary, and then I'll show a little bit of code just to see what we have here. So again, GraphQL or DynamoDB and GraphQL summary. Biggest thing I would say is make sure that you understand DynamoDB first, right? DynamoDB is a little different. You have to think of those access patterns first, but you need to learn DynamoDB modeling in GraphQL just like you would in any other application. Second, understand the trade-offs between single and multi-table design. Do you want more complexity with lower latency, or can you tolerate a little bit more latency and reduce the complexity? And then finally, make the decision that's right for you. Just to close this out here, I want to walk through a little bit of the code from those two sample applications. Again, go check out those applications. Go check out the write-up for the full story on this. But we can see a little bit of what I'm talking about in the different levels of complexities in the resolver. I'm going to start with the multi-table DynamoDB design that we had. And in our GraphQL schema, we have this get site query that we showed before. It returned this site object. If we go look at that site type definition that we have here, again, it's got some scalar values, but it also has this one-to-many relationship of posts, right, that we need to be able to handle. Now, if I'm using multi-table design, I'm going to look at that get site query request. And this is written in VTL. You can do it in Lambda as well. But the nice thing about this one is it's a pretty straightforward operation. I'm doing a get item request, which is just a DynamoDB request to retrieve a single item by its primary key. I'm passing in that primary key from the argument that it gives me. There's not a lot of logic in my actual VTL, as we'll see. We'll compare that with the single table design in a second. Likewise, with the response, I can just return the response right back to the client that's calling me, right? But that's only going to get the site for me. And what if they're also retrieving the post? How do I handle that? Well, then I have also a post resolver. Again, this is a field-based resolver for that one. But again, this is a pretty declarative template we have here. There's no if statements, there are no for loops, anything like that. We're doing a DynamoDB query operation. We have to specify the DynamoDB expression. This might look a little foreign, if you're new to DynamoDB, but trust me, this is actually like a pretty straightforward implementation and not a lot of work we have to do there. Also, if we're looking at the response, we're basically just sending that back. Now, I want to compare that with the single table design code. So I'm going to switch over to that now. All right, so here's the code for our single table design repo. Again, doing that same get site query we have here, but now this is a little bit more complicated, right? At the beginning of our template, we have to do this if statement where we do that look ahead, right? So Breeze talked about the selection set. What we're doing is actually looking ahead and saying, hey, does that selection set contain the post field? If so, I need to change some properties in my DynamoDB query that's going to happen because, I'm not just fetching the site, I'm fetching the site and 10 of those post objects as well. So it's changing how many actual items I'm retrieving from DynamoDB, and then I'm putting it into my query. Likewise, the response I get from Dynamo, it's going to give, it might give me 11 items back, one of which is a site, 10 of which are posts. So let's look at how we have to sort of unparse that, right? So what we're doing here is we're looping over the items we have back and looking at the type of the item. And hey, if it's of type site, that's our main site item, and we're setting that attribute there. If it's of type post, then we're going to add it to this post array that we're keeping. and returning that back. So it's just a little bit more work to sort of both make that initial query, to do that look ahead in that selection set list, and then also to deserialize the result and put it into our GraphQL response. Again, none of this is impossible, but you're just going to add a little bit of complexity into your query there. Anyway, that wraps it up for this session. Again, thanks for joining us, and thanks for Breeze for walking through AppSync and GraphQL. I hope you enjoyed this stuff on DynamoDB, and we're available for questions if you have any.